Okay, let's go with the next speaker. He's Ramon Navarro Bosch, CTO in ONA.io. He's very well known in the open source community also, from being a member of the framework team of Plon and TensorFlow engineer. Thank you very much. And his talk will be about Guillotina, an Async REST Resource DB to manage millions of objects. Thank you very much.
Thank you very much. Well, he nearly said everything about me. I'm co-founder and CTO of ONA. It's a San Francisco and Barcelona company. Our main mission is to connect and search all the knowledge inside an enterprise using machine learning. Just kind of Google, but for inside the company with all the resources, connectors, all the places, Slack, Dropbox, Google Drive, or whatever, connecting everything and being able to search. We just got Gartner pointed us as one of the cool vendors of this year. And I'm really enthusiastic about open source. I've been on open source nearly 20 years. And I'm a member of the Plon Foundation, a US foundation for open source, and also on the framework team of this Plon software. And I'm a web framework engineer. So I'm not a data scientist, so my main goal for this talk is that you don't kick off me off the stage before I end the talk. Because I really want to we tried with this software to build something that is from both worlds, web environments and data scientists. So first, a bit of background. One of the most common problems we are facing when we are doing data scientists or whatever algorithm we want to do is that we need to have the data. We need to clean the data, we need to get the data, and normally it's a big fight between engineers, sysadmins, that have a database or have a lot of data, and the data scientists that want the CSV file. I just want the CSV file. But the data is in this SQL, wherever place, I need to extract, oh my God, this is going to take me 1 month to do this work, no? And this is one of the most common problems that we are facing, and it's an engineering problem. So we are trying to find a solution for this problem and not having a fight, so we are friends. The other background idea is that most of data scientists always think about tables, no? CSVs, row columnate information that is structured on kind of categorical, numerical variables. And in a table, our users love that for data tables. But the wall outside, on the engineering outside, it's a bit more complex. We have non-structured data, we have JSON data, we have documents, we have information that has multiple levels of nested soup information. So what I'm going to explain, it's more oriented to the NoSQL wall, where information is not structured in a table and can dynamically change. Tomorrow we are adding a new field, we are removing one field, etc. So what happens with web frameworks right now? Well, web frameworks are nearly dead from the point of view that rendering a page, an HTML page. Nobody right now is focusing on building web frameworks that renders an HTML and adds a CSS and these kind of things. Either Django, for example, one of the most committed repositories from Django is the REST API, because everybody knows that all CMSs, all web frameworks needs to provide a REST API. And there is a lot of really good technologies in front of that, Angular and React, for example, that allows you to build the front end, the user experience from the user. And we really don't need to develop the rendering on the back end. So what will happen with these web frameworks, Django, WebPy, Pyramid, Plon, they will need to evolve to a REST API, and at the end, it's a data framework. It's a place where you push information and you get information and you can modify information. So it's more connected to data. And all the web developers, all the web engineers that there is around all these projects, they have a lot of knowledge about the scalability, about the storing information, how to do optimal things on production environments. And I think it's really important that we connect these two worlds, and we make options to have the web framework connected to the data scientist backend. So this is my main goal with Guillotina, is that the web framework communities and the data scientist communities can live together, and they can work to have connected live data web frameworks with data scientist frameworks. So the same place where the real data is pushed, where the application it's managed, where the engineering team, the production team is pushing the information, it's the same place where the data scientists can get the data and process training models, and they can do inference and whatever it needs to be done there. So first, I'm going to also, to be in the context of what's Guillotina, I need to go back in history. I need to go 18 years ago. There was Zope and ZODB was created by Zope Corporation. Zope Corporation had two kind of lead engineers. You may know Guido van Rossum, the creator of Python. So he was working on Zope, and he was one of the creators of Zope, with Jim Fulton, who created the ZODB. It's an object database oriented to store information in append mode. So they created this piece of software 18 years ago. Python was nearly 2.0 version. So they needed to build everything. Python has no libraries nearly, so Zope needed to build all the needed workarounds to solve the problems that Python had at that moment. And it was a really good piece of software, enterprise-oriented, with a lot of security, and it was a way to have an application running on your servers. 16 years ago, Plone was created. Plone is a CMS that it's a layer on top of Zope. Does anybody does not know what's a CMS? Content management system. It's kind of, everybody's going to kill me if I say that, but it's kind of a WordPress, but for enterprises, okay? So it's a really good piece of software. It's been there for 16 years. A lot of big companies are using that for managing their content inside intranets, different kind of applications, CMS, web e-commerce applications. A lot of things are built on Plone. 7 years ago, the guys that were still on Zope decided to do something new. They called it Pyramid, and they merged a framework called Pylons and repos BFG, that it's a Zope fork. Then 2 years ago, the Plone community, that it's 500 more or less active developers there, they decided to build a REST API. Because they were kind of seeing what I said at the beginning, that web frameworks are dead in the terms of rendering content from the backend. So they built the REST API, and it really works really well. It's really stable. It's improving a lot, and it's a really good piece of code. But the problem of Plone is that it has 300 Python egg packages. So because it's so big, it's been there for 16 years, that there is a lot of code there, a lot. It's nearly impossible to maintain that kind of thing. So 1 year ago, a group of people inside the Plone community decided to rewrite from scratch all the Plone backend using only Python 3.6 and Async IO as the main engine to serve requests. So we decided to take everything that we have on Plone, all the knowledge, all the expertise that there is there for 16 years, enterprise-oriented, and create a new framework that we called Plone Server at that moment. Half a year ago, somebody was kind of annoying us, saying, if you call it Plone, it's like it's Plone, but it's not Plone. So we decided to change the name, and we created Guillotina. Guillotina is a framework oriented to create REST APIs that it's based on Async IO with Python 3.6. And it manages all the data modeling, all these kind of things. So I'm going to go a bit over the functionalities of Guillotina and what it's exactly. So the first point is that it's transactional. So everything that you do on the API from Guillotina, it's going to be persisted on the database, and we can assure that it's going to be there. So there is no possible of losing information or kind of not confirmed writings on the database. It also provides conflict resolution. If two people are writing to the same object at the same time, it provides a way to solve the conflict there. All the information on this REST API, it's stored on a tree. URLs are a tree-based kind of model. If you go to /a/b/c on a URL, at the end is a tree. It's a data structure that can be mapped on as a tree. So all the data model is oriented on a tree model inside the database. Each resource, each object that we have on the database has fields, has a schema to validate the fields, it's object-oriented, it has inheritance, so you can have objects that inherit from other objects, and have static and dynamic behaviors to change the amount of fields that we have. We will see some examples later. In order to interact with the user, in order to provide a way to connect data, send data, and retrieve data, we are using JSON schema, one of the standards on the API wall, and we have direct mapping from JSON schemas to Python schemas. Security is a really important piece from Guillotina because it comes from an enterprise CMS, and it allows to define for each object, for each folder, for each element on the tree, who has permissions to see, who has each permissions to delete, who can get some information from there, who can compute something on that object, etc., etc. And it has inheritance of permissions also. You can set somebody has permissions to this object, and all the objects inside that tree will have permissions to do the same if you want. It has a CRUD. CRUD is create, read, update, and delete API, so you can do whatever you want with the objects that you have on your database through the HTTP verbs, and you can specify your own endpoints there. It's Async IO. It's based on Async IO. It's one of the first full high-level frameworks that provides Async IO on REST API. That makes really, really good results on performance and scalability, because it's not blocking for getting to the database or doing whatever network operation you need to do. So it really scales up really, really fast. Like, if anybody's interested in the numbers, I can show you later which numbers do we have here. It's based on HTTP, one of the best libraries for doing HTTP serving on Async IO on Python 3.6. It has cores. Cores, it's something from web. It allows you to query from different browsers without any problem, embedded on the system. It has WebSocket, as it is Async IO. It allows you to define a WebSocket connection where you can do transactions, or you can do operations to your data model through this WebSocket connection, get feedback. For example, later we are going to see how we can train a model and how you can get the feedback of how is it training the model through the WebSocket connection. It has TUS, that it's one of the protocols to allow upload and download of files in resumable and in batch mode, so you can do different batches to push a big file to the system. If you want to, you still can push your CSV file if you want, but you can use TUS to make sure that it's resumable and there is no problem on transaction mode. It's event-based. All the stack it's built on Async IO, on Python, so we support events. So you can decide if anybody push an object of this type, do something, train something, apply this inference, apply whatever you want to do with that object in real time. There is a registry. Registry is a place where you can write down your configuration, some specific values. You want to, for example, you want to store the hyperparameters for your models, wherever, you can store in the registry. There is a queue, an operational queue in the process itself. So you can decide, you can say to the process, hey, I need to apply this thing, I need to do this operation, and that needs to connect to these places and do wherever you want. And you can have this queue of operations where you can add them, and then it's going to be executed when the CPU has time to do it, without stopping serving a HTTP request to the client. It supports multiple databases. You can mount multiple databases in the same API. So for example, you can decide to have distributed databases, and they are mounted to different URLs where you can decide each one. Right now, we have full support for PostgreSQL, and we are going to release soon the support for Cockroach. They just released the 1.0 version last week. Cockroach, if anybody is not knowing, is a distributed database that allows you to scale horizontally without a lot of performance loss. It supports distributed transactions, that it's really great. And it has the same API protocol than Postgres to be able to talk with it. On these databases, what we are storing is not column information. Besides the RSQL databases, it's pickle. We only store pickles there, so our schema of data can be changed at any time on the life of the product. We also have packages to support storing large files and binary files on S3 and Google Cloud Storage. We are going to open source soon the local distributed file system to support storing large files on a local distributed file system. We support indexing. If you want to be able to search across all your data, you can install Guillotina Elasticsearch. It's a package that automatically maps your data that you want to be able to be searchable across an Elasticsearch cluster in a way that you can decide each field from your schema, how do you want to map on the Elasticsearch. And Guillotina takes care to maintain the synchronicity between the indexer and the real database. It has distributed cache. That means that you can scale up this really fast, and it will go always really fast because there is a cache that with PubSub, it provides invalidation of objects to each of the front ends that you have. It has Swagger. So I don't know if you know, but Swagger is one of the standards on OpenAPI standard for writing APIs. You can write your code and automatically generate the API from Swagger in a way that you can build your connectors in any language that attacks this API. It's built from containers to support in containers, and it has some great functionality on Kubernetes, for example, in order to scale up automatically if you deploy Guillotina on Kubernetes environments. We are adding support to Nomad, a new orchestration engine. And everything is written with explicit Python, so everything is in the code. There is no much configuration file, and you just write your information on the Python code. So Guillotina, it's how we took this 16, 18 years of knowledge of Joe Plone, and we took the minimal thing that is important, all the knowledge that there is on the platforms, and we built something from scratch with that knowledge. The only package that we are still using is one. It's called Zope interface. So I've already explained it, that the API, it's what we call a traversal API. Traversal API, it's a way that you can map on the URL the tree that your database is hosting. For example, in this case, the first element on the URL is going to be the database. Then the next one is going to be the main container that you are creating, object, and subobject, and subobject. And then you can access, do operation on that objects using URLs directly. So a bit of summary of what's Guillotina. It's only Python 3.6. It's designed to host millions of objects. We have some instances with 10 millions, 100 millions of objects without any performance problem. It's able to scale it really, really fast. And it's stateless, the API by itself, so you can start as many API frontends as you want. We really had a really good work on memory optimization. You can run a Guillotina on 50 megabytes of RAM. If you want, if your objects are going to be really big, you need to at least have 4 times 1 object of the size of the memory. But it's really optimized on all the operations to not consume a lot of memory. It allows us to apply operations to the objects in async mode. So you can say, just calculate this for all the objects, and then it's going to take care for you without stopping serving. All the security mechanism is really important. So authentication and authorization, it's really a core model from the Guillotina. It supports OAuth DOS flows to be able to connect to different OAuth providers. And it has a modular API to, if you want to extend to your authentication system. And one of the cool things is that as we are doing the same API that Plum has, if you really need to build some UI for managing this content, you can use all the UI widgets, applications that the Plum community is building to be able to manage this information. So it's, if you want to have some kind of CMS on top of your application, of your data, you can have it because you already have a front-end application built on React or Angular that it's able to attack the same API and do the same operations on your database. Okay, so this has been a marketing talk. I've been selling you a lot this framework. I'm the main author, so you can understand why I'm selling this so much. So, but I really want to show how easy it is to try it, okay? So this is a configuration file for Guillotina. So the only thing that you need to define is where you have your database, your Postgres database in this case, which transaction conflict resolution strategy do you want. We have multiple. One of the most common one is to resolve the conflict. You define which is the schema, the user database, which is the size of the pool that you want, on which port do you want to serve the API, some static resources that you want to push, which is the root password that allows you to bootstrap the API, the course configuration, and some utilities. So this is a small config file. It's everything that you need to try Guillotina. How do you do that? Quite easy. First, we need a database. So in order to do a database, first, we're using Docker. We can just bootstrap a Postgres, create a database. It's called Guillotina, pip install Guillotina, Guillotina-c, the config file that I was saying. And then you automatically will have your API serving at 8080 port there. How you can play with that? Okay, it's quite easy. You can do gets, posts, and patch, and gets and delete. So first, we can get which is the information that there is on the root. We can access to the root using the admin user password. And then we can start to create content. How do we create content? So just pushing JSON to the API in a normal way. So we do a post. Post means creation. We create a container. We call it ID container with the title My Lovely Container on this endpoint. That is the database that we mounted. This database, this DB name, it's the DB name that we have here. We can have multiple databases mounted on the same API. So we create the container. We can create a folder inside this container with this URL. You can see now that the base URL where we are doing the post is the URL from the container we created. And we can create another folder, and we can create an item inside this folder, and we can modify the title from this item on this folder, and we can get again the item, or we can delete the container itself. So all the operations to create, modify, just HTTP request to the API. And we make sure that if this says 200, this is going to be stored in the database, for sure. So which is the data model that all these objects has inside? We already seen that it's a JSON file there, but we split the information into kind of models. So the data is stored in the main object, we call the resource, where there is a schema that defines there is an integer, there is a float, there is a text, there is a sub-object, whatever you want. And then we have static behaviors and dynamic behaviors. That is another schema with other fields that we can apply dynamically to the objects to extend the object in any moment. So for example, we can have a shopping cart. So shopping cart is an object where we have a list of fields, and then we can decide that this shopping cart has a behavior to say which is the shipment process. And each behavior can have semantic or different fields there. So a bit of code. How we define a content type there. A content type is just an interface that we inherit from an item, for example, and we just define this is going to be a text or a number or a float or whatever. And then you define with a decorator that the content type has this name, belongs to this schema that we define here, and has these behaviors that you can define later. So this is enough to create your content type. You can define as many content types. This is quite similar to how Django is doing, for example, his ORM with SQL Alchemy, or any other of the web frameworks that already exist, how to do the mapping of the objects to a database. So this automatically creates this kind of object, and we can create them on the database. How we do an event, for example. Imagine that we want to do something that happens when we create this object we just created. So we just configure a subscriber for this interface that is the object that we define it. With this event, we added this content, and we can define any async code here that is going to happen when somebody creates this object on the database. Then how we do our own endpoint, a place where we are going to be able to call and do some get operations. So we can define the permission, the name, and the method that we want. And then just on this async call, you can write wherever you want that it happens when you call this operation. So this, it's what is Guillotina right now. It's completely stable. It's used on production. Some other companies are using it a lot. At Ono, we are using it a lot also. So if anybody wants to try, feel free to open issue on the GitHub repository. It's really great. What I really want to show now is what we are working on the core contributors for the next versions that we are going to push. These are work in progress. Most of them are already finished, but are really more oriented to the data scientist world. First, what we call the distributed hive. So as I explained, this stateless API, this stateless web framework allows us to bootstrap many of them and without any problem because they are stateless. So we decided to be able to create workers for this API. We can bootstrap a different amount of guillotinas that are in worker mode, and we can distribute operations across all these workers. So imagine that you need to modify all the objects from your database, or you need to modify all the objects that are from some specific type, or you need to do some kind of operation there. Then you can just start an action, a task that is going to be distributed along all these objects to be able to apply to all the amount of users that amount of objects that you have. It's based on an etcd for discovery of the different workers that we have. We support dynamic bootstrapping of different workers. there is no aggregation callback. So right now, you bootstrap all the tasks, but you don't get any result. It's just in async mode, it's going to be done, and when it's done, it's done. But it's something that will be great to do. And I really want to thank you, Nathan Bangizi, that it's the one who contributed more in this package, because it's a really good piece of work. This is going to be called Guillotina Hive, and we're going to open source in the next weeks on the repository. So how does it work a bit? So just you define your task, that your task does whatever. In this case, it's just getting the object. And then in your code, this is on the worker. In your code, you just get the utility, I have utility, and then you can define this task with the name of the task, and then the parameters that you want to send, and then you just push this task. So all the workers are going to receive this information, and it's going to distribute the load of the operation on the database. Other things that we are building, inference. So we are using TensorFlow serving. We use a lot of TensorFlow for a lot of things at ONA. So we built a model for Guillotina that allows to bootstrap a TensorFlow serving model that it's C, and just with a specific TF loader adapter that gets a model to apply the inference from the API. So you can store the model on the API, and the serving can decide from multiple models which one needs to be used to do the inference. So at the end, you have a URI from a resource. You decide to apply a model, and you put the URI of the model, and automatically gets the first TensorFlow serving that may have this model. It just sends the information there and applies the inference and updates the object with the information that it's been discovered from that object. And the most experimental thing that we are working, and that I'm really happy about the results that we are getting, is distributed training. We have the information on the API itself, so all the model information is there. So we thought, can we train dynamically models using TensorFlow? Just getting all the information. We already have all the data there, so it's just a matter of connecting the two worlds. No? So yeah, we have really good results and a good proof of concept right now that bootstraps workers using TensorFlow, distributed TensorFlow, so bootstraps parameter servers and bootstraps workers, that they get connected and automatically synchronizing using etcd. Then we have our own TensorFlow operation that adds access to Guillotina REST API, so all the input variables are retrieved from the REST API itself. And then we support we are playing just right now with the reinforcement learning support, so it can apply reinforcement learning based on the information that we have or the interaction from the user. As in a Sync.io application framework, we can connect things, and all the interaction, all the information that we are getting, we can send to this TensorFlow model. And the coolest thing that we started 2 weeks ago is there is inside the Plum community, there is something that's called restricted Python. It's a package that allows us to define a subset of Python operative that you can execute. So to make sure that you are not doing crazy things on Python, and providing the option to write Python code from the web. So you can define a piece of Python and execute that inside your environment. So we said, what can we use this technology that we have already on Python 3 to write down the architecture that we want to run on TensorFlow from the data model point of view, and then just send that to the workers to be able to execute this architecture. And it works. We still need to publish a lot of things, and we still need to solve a lot of problems there, but at least it works. So we will be able to allow our data scientists to kind of write down the architecture they want to try and just push to train something with all the data in the same production environment that we have. So the main problem that we are facing, and if anybody wants to solve it, gRPC has no async IO support, and it's a big problem. And if anybody wants to contribute solving this problem, there is an issue tracker on gRPC repository. gRPC is the protocol that TensorFlow is using for communicating all the processes. This is made in Barcelona. This was created here. And we have a really good community. Asko and Nathan and Albert are the main contributors to the product, but we are still open to a lot of contribution. If anybody wants to help on this product, we are really open to welcome people. An announcement, we are going to do the Plum conference on October 16 in Barcelona. It's the first time we are going to do this conference in Barcelona. It's going to be a really important international conference. So if anybody wants to attend, we are going to discuss about these things and a lot of other techniques about async IO, about front-end, about Angular, about React, about all these technologies that affects nowadays web development. And that's all. Thank you.
Thank you very much, Ramon. Do you have any questions? Raise your hands. Questions?
Well, how mature is this framework? Is it already being used in the industry?
Yeah. So as I said, we should shut down the cameras because I'm not allowed now. We are using in production at ONA. We know some other companies that are using, and yeah, it's ready for production. It's stable. It's really well tested. It's a lot of performance tests has been done there. There is automatic testing of any commit, and there is high quality knowledge. And it's mostly everybody that's contributed comes from 16 years of blown knowledge. So there is really a good knowledge for building this application. It's not really old, and so Guillotina itself, it's 6 months, but we came from Plone Server, so we just changed the name, and Plone Server has nearly 2 years right now. So it's it's stable because we are using, and we have no problems of memory leakage, and it scales really. The core, the different plugins that we are building may be more unstable there.
Okay, thanks.
More questions?
Well, first, thank you for the presentation. I think this is a very nice piece of software. It does almost everything. I don't know, you've been developing for 2 years, you said, with people with very good experience. I'm curious about, I don't know, you mentioned, does it has a kind of index first to search for objects or something? Because you have the traversal API, but what do you want to find all the objects that have certain attributes or whatever? And also, what about the performance of mass operations? There's this thing that you mentioned about the work in progress, but for example, I'm imagining, what about if I modify the schema of some, or the interface in this case of some object, and I need to add a default for this field for all the objects, and then if the system needs to unpickle everything and change something and then pickle it again and save it, if I have 1 million objects, it's going to take a lot of time, or more than in a column-oriented database, or how do you solve this?
Well, I understood the question about indexing. Indexing itself using Elasticsearch. So we don't want to support indexing in the database itself because it has a lot of problems on transactionability, and it adds a lot of overwhelming the CPU and how do we do indexing. So we are using right now Elasticsearch. We have an open source plugin for indexing everything that you want there. I did not understand the second question.
I mean, since the way the database is done to store objects, you have to do a massive operation like update for all the objects of this kind for these fields, put here 5. How is the performance for this? Because it needs to wake up all the objects. I remember in SOAP you have this issue where you're migrating and then that's...
Yeah. So in order to solve that, the main way of doing massive operations, it's not based on content type, it's based on the tree, for example. So Our main use cases that we've seen, and we needed to apply this kind of techniques. It's not applying for all these kind of objects. It's just applying for everything that relies inside this folder or inside this node. So the architecture of the database that we are having is not ZODB. We don't use ZODB there. So it's our own database model. And we designed this database, our mapping model, oriented to have a really fast waking up of objects that are nested inside a tree. So it's the way that we can have high performance of doing walking across all the objects inside the tree.
More questions?
Yeah, since the data is pickled in the database, how do you handle schema evolution over time?
Well, so the schema, it's on the code, and what we store in the database is the pickle, no? So there is no, you can define to write tomorrow a new field, and there is no problem, because it's going to be the default value that is going to be there in case that it's not on the pickle, because the objects from Python allows to define, it automatically wraps the set attribute and the get attribute from the Python object in order to provide default values in case that it's not in the database. In case that you're removing a field, there is no problem. The pickle will have that on the database, but you will not need to have that on your schema. So there is really few cases where you really need to go to update all the objects on if you are modifying the schema.
In case you are renaming all fields?
Yeah, in case that you need to renaming, but it's really few more of cases that you are renaming an attribute. It's more that you are adding new attributes. We are adding attributes every week, and we like that because we are not able to define the model from the day one that is going to survive forever. No? So it allows us to do that without problems.
Thanks.
So I think it's time for lunch. Let me tell you that this afternoon we have lightning talks also. So if you want to give one lightning talk, go to the whiteboard and write down your title of presentation. And now give a big applause to Ramon and his Guillotina framework.